to all students. This is live session for the integration 8th part. So soonly in our website, I will provide those who are in my website and my chat. You can see this in the website and you can write down the exam online fee. So we provide each and everything. I'm updating it under the development phase. So for attending online, you can here. Oh, I didn't share. Did I share the screen? Hmm. So now, so we already solved few questions here. I come back to again this material. So today we are going to worksheet 4. Coming to worksheet 4, see content related to content. Can you see this question?
Yes, sir.
What is the question?
Integration of 1 by
Speak loudly. Speak
dx
loudly.
plus 2 into dx.
Speak loudly. थोड़ा जोर से बोलो.
Integration of dx by x square minus 3x plus 2.
How can you do this problem? 7:40. The class will continue till 8:30.
Sir, first we'll differentiate. I mean,
How?
sir, rationalize.
Rationalize. Now it is
Sir, first we'll find the factors.
factorize.
Factors.
Just to give me a second. That is my marker.
So
Sorry.
x square minus 2x
Wait a
minus.
second. Wait a second. So here it is not. So you have to do some factorize. So whenever the quadratic equation, it is a kind of help. You can do bifurcate easily. You can do by parts easily. It is an integral by parts. Okay. So it is an integration dx and do on some rough work. See, soon after, do you know, after your long practice in the 8th class or 9th class, in the 9th class, I already taught the quadratic equations. Do you know how
Yes,
to factorize this without doing anything? You have to think like it. It is just you have to attempt. It is x minus 1 into x minus 2. How I got this idea? Okay. Did I made any rough work? No.
No.
How
Sir,
I did?
multiplication and addition of the factors.
It must be x minus and x minus. That's it. It is a quadratic equation. I say you know.
Yes, sir.
So please just you have to small calculation. It is minus x minus 2x become minus 3x and minus into minus become plus. That's it.
Plus.
Okay. If this is minus, so you have to think one is plus and one is minus. But that is up to your practice. अब आप practice नहीं करोगे तो मुश्किल है. Okay. And you need a lot of practice to get this kind of understanding. And now, why I removed this means I need it 1 and dx is here.
Yes.
And then after that, again, it is a hit and trial. There is no need to go for a by something factor plus b by something factor. We need to equate the coefficients and all. That is total the process of the partial fractions. Here, just make by x minus 1 by x minus 2. So if I make 1 here, what happens? X minus 2 will come. Okay. If I make it is plus, what happens in the calculation? It will provide, if I make it 1, what happens here? X minus 1 into x minus 2 in the denominator, that is clear. And here, x minus 2 will come and plus x minus 1 will come. But is there any cancellation? We don't want x, we need only 1.
Sir, will multiply.
No multiplication. Where is multiplication? Here.
So by multiplication, you can multiply 1 by x minus 1 into.
No, it is plus. It is plus. It is plus.
Sir, why?
Because it is by parts. Integral by parts means it's a by parts. Oh, no, it is not by parts. It is a partial fraction. See, 1 upon x minus a into x minus b can be partial fraction. Here, a by x minus a plus b by x minus b. This is called integral. No, this is called partial fractions. Either plus or minus it will be happen. If you make it multiplication, there is no use. Here also the same. Nothing we are doing with multiplication. And here what we have to do still why I removed this means, so here what happens if you take plus, it is x plus x is remaining, we don't want x, so we need minus. If you do minus, it is minus 2 and it is minus of minus plus 1, it is becoming minus 1, so we need plus 1 means I am writing here 1 upon x minus 2. We need plus minus here, minus 1 upon x minus 1. Now everything is simple. Just dx. Think
Yes,
I
sir.
written directly from this form to this form. If you want a proper technical banda, then you need these are the okay. Is it clear?
Yes, sir.
And actually in the academics, what happened in your school? Okay, this is A by something, B by something. Okay, what I will do? I will do what is your school process. Okay, the school process is this is a school process. This is equals to so and so plus. So immediately you have to write in this form. And then after that, you have to write the LCM. It is x minus a into x minus b. And it is a into x minus a plus b into x minus b plus b into x minus a. Then these two denominator get cancelled. And 1 is equals to, you have to take x common, it is a plus b and x, and it is plus a b plus b a. It's a headache. It's a complicated question. It's not easy. These are the numbers you can get simply. But and then after that, x coefficient 0, a plus b is equals to 0, and another equation will come from here because it is a constant. Constant must be same. Something 2a plus 3b is equals to 1. Then you have to simplify and get a and b value. Then you have to substitute here. It is no, we should not do this kind of practice. It is a traditional. It is useless practice. Okay, so but you have to do such a fast, it is a minimum requirement to do simplify the less calculation with. Okay, so here how I retain this 1 by x minus 2 minus 1 by x minus 1, the basic understanding about how we can manipulate. So then now integration will be separated for each term. So what is x minus 2 derivative?
1.
1. 1 is in the numerator. So denominator function का numerator होगा तो what is the function? What's the answer? If denominator's derivative is in the numerator, then what is the answer of the integration? Integration f dash x by
Log of x minus 2 by
which is log of mod x minus 2
mod x
minus log of minus log of mod x minus 1. The इसकी derivative is also 1 and plus c. And you know the integral logarithm formula, which is log of mod x minus 2
a
by
by b is x
mod x
minus 2
minus
by
1
x minus
plus c. Mod you can write, this is mod a by mod b or mod a by b. Both are same. No issue. If it is here mod x minus 2 by x minus 1, this is option number 3. Clear?
Yes, sir.
But you have to do all these things. Now it is a one more question. One more question. We have to do now. What is the question here? Integral x plus 1 by x square into x minus 1. Now, how can we do the partial fraction is most important. Doing partial fractions is most important. And for that purpose, I will open our previous. In my notebook, I think we have the material. In this, you have the book. In this, you have the content of integration. Content is not my matter, my work. So just we have to look into that content. Have we look into here? Let me check my live session is working fine. Yeah, it's working fine. Think we have to do this practice of worksheet 3 again. Okay. So integral and rational functions using partial fractions. Can you see this heading partial fraction?
Yes, sir.
Hmm. So now here how to do the partial fraction to the rational function is most important. Okay. So here see, can you see question example? What it is? Integral 2x minus 1 by x minus 1 into x plus 2 into x plus. So here he did by a by x minus 1 plus b by x plus 2 plus c by x minus 3. Then he got the a value is minus 1 by 6, here minus 1 by 3 and 1 by 2. That is the thing you have to do a lot of practice. Okay, it is second case. See what happens here if it is a rational function a naught by x minus x naught plus b naught by x minus x naught whole square you have to take. Okay, so when it is g of x is of the form, in the previous case what is g of x is of the form simply x minus a into x minus x1 into x minus x2 into what are the powers of these factors? One only. So if all are simple factors, then no problem. You can take a, b, c, d. But this is now, if it is something x minus a whole power k, so you have to take one term with x minus a1 plus second term with x minus a1 whole square up to k. All are factors. You have to take with the squares and then simple factors. If it is any another thing is repeated, you have to take in the similar way. Is it clear?
Yes, sir.
So see here in this equation, in this question, the x square numerator is not an issue. We don't care about the numerator, but denominator is an important. So here x minus 1 square into x plus 3. So this is equals to a by x minus 1, but its power is 2. So plus b by x minus 2 whole square, that is, it is not clear. Okay, it is x minus 2 whole square plus c by x plus 3. Now do fighting, take LCM and all and compare this equation numerator x square plus 1 is equals to a into x minus 1 into x plus 3, b into x plus 3, c into x minus 1 whole square. It's a LCM. Then he got what are the a, b, c values. Then he substitute that. So this is a partial fraction. Then he is doing, so this is 3 by 8 integration 1 by x minus 1 plus 1 by 2 integration 1 by x minus 1 whole square plus 5 by 8 x minus 1 x plus 3 whole integral 1 by x plus 3. So its integration is log mod x minus 1. Its integration, the third term integration is log mod x plus 3. What about integral 1 upon 1 x minus 1 whole square? It is just like integration 1 by t square. It is t power minus 2. Then minus 2 plus 1 by minus 2 plus 1. This is the integration of 1 upon x minus 1 whole square. Then that's a simple answer. Now next case, the denominator is quite different. So if any of the factor with a square, then in the numerator you have to take bx plus c. It is not x plus 4 whole square. It is x square plus 4. We can't bifurcate. Is it clear?
Yes, sir.
This is the third form of the integral. See case 3. Case 3. This is the third form of the integration. So here a upon actually it is a source code. No? I think it is a source code. You can see it is a part of syllabus. It is a part of syllabus. It is most important. You should know all partial fractions. We can show it to you. What is our syllabus? See, everything is part of syllabus. It is integral by dx by square. Some terms with squares also. For these x square plus 2, x square plus minus a square, everything is a inverse functions. Everything you have to understand the basic understanding of each and every terms. Okay. So here, whenever quadratic equation as a factor is there, unable to factorize, then you have to take the numerator as bx plus c, and entire function wherever x square is there, you have to take bx plus c. Then fighting LCM, then simplify, and then you will get these kind of answers. Then simplification. So now there is a fourth kind of factorization. See what happens. This is ax square plus bx plus c whole square. So for ax square plus bx plus c, we keep ax plus b. For first factor, you have to keep ax plus a1x plus b1. And again, it is a repeated fraction. Means repeated factor. Means for square, it is a2x plus b2. For cube, a3x plus b3. For k, you have to continue. So this is highly complicated. You can see x square plus 1. For x square plus 1 itself, ax plus b. Can you see? And for x square plus 1, again square is there. So again it will come cx plus d. Then multiply, then simplify, then so and so, you have to get the answers. So this is the most important. Our student is there. What is Shivika? What is her name? Shivani Krishna.
Yes, sir.
Same technical. She's technically she do bifurcates. This bifurcation is important. Okay. See here in my hometown, you know, it is Sirisilla.
Yes, sir.
Okay. So we are the weavers below family. I belongs to weavers family. So when this is a cloth, okay, it is made up of with long threads only. So what happens in some cases, a piece of thread group, sometimes it will damage. We can't take one thread. So with carefully we have to find out its root and simplify that to get simply the thread has to come outside. समझ में आया?
Yes, sir.
तो नॉर्मली जो धागा होता है ना, वो एक रॉड के ऊपर घूम के रहते हैं. अगर वो पीछे से खींचेगा ना, वो धागा की जो फ्लो है ना, वो बंद हो जाता है, वो सीधा नहीं आएगा. तो फिर वो मिक्स होने के बाद धागा सीधा थोड़ी निकाल सकते. अब थोड़ा सा पेशेंस चाहिए इस समय. थोड़ा सा चारों उंगलियों को इधर से उधर से करके ऐसा करना पड़ेगा, तो फिर ऑपरेशन करना पड़ेगा. ठीक है. So that is the important technique. So this is the same way, and you have to remember these are the four methods. Actually, there are not four methods. There are the three methods. Fourth one is repeated only. It is three crucial methods. So now see here, and you have to use all these kind of formulas. Integration dx by x square plus bx plus c formula. That is the proper IIT notation mentioned symbol. So 1 upon a square plus x square. You should understand it is 1 upon a tan inverse x by a. But dx by a square minus x square, you should not apply this formula. It is a square minus x square. It is 1 upon 2a log a plus x by a minus x. Okay. See, whenever you see a square minus x square, so in the keep in your mind, so is it friendly to factorize? We can't make it factorization, but we can make this as a factorization, a plus x into
a plus b minus.
Once it is a linear, it is a simple equations na, a plus bx form. So when it is simple, once it is simply factorized, so you no need to remember this formula. Okay. So here in these two formulas, what is the remembering formula is only the first one. Second one is simple. It is a square minus b square, a plus x into a minus x, and we can do some suitable manipulation to bifurcate, then denominator derivatives in the numerator, and apply logarithm and logarithm formulas to get the final answer. Next, it is simple. So even x square minus a square is also. The only difference is minus. If you keep minus, what happens? If you keep minus, what happens? It is a front. Minus can go out of the integration also. So it is minus 1 by 2a, and this minus 1 can go to the numerator. That's a power. What is a power minus 1? It is 1 by a. So it forms a reciprocal. It becomes a reciprocal. Is it clear?
Uh,
And here a greater than x, because if a less than x, it becomes a negative. That is the problem.
okay.
And here also x greater than a means x, if it is x less than a, it becomes a negative. That's the problem. Okay. The most toughest thing you have to remember is gx by a square plus x square is equals to 1 by a tan inverse x by a. So for this, I should also remove those formulas. Okay. In my list of formulas I sent the document. We'll see. So it is, and here also you can remember what happening here. He is using x is equals to a tan theta. So dx is equals to a sec square theta, and denominator 1 plus tan square theta, sec square theta gets cancelled. It is 1 by a theta, and theta is tan inverse x by a. If you remember this proof now, so you no need to remember this formula also. Okay. So in this case, you have to take x is equals to a tan theta. It is a substitution method. And next, so this is another case, denominator is under the square root, make it try to square, it is integration of, replace this by what we are doing. It is becoming a tough job to understand. Integral under root of ax square plus bx plus c. So he totally replaced this ax square plus bx plus c by the derivative whole square by 4a minus delta, where delta is equal to b square by 4a. You should remember. So actually, don't do any remember. It is useless point. Try to make this as perfect square. That's it. Try to make this as perfect square. Try to make it as perfect square. So denominator, some number will come, send it outside, no issue. Okay. And it will not become perfect square. If it becomes perfect square, then what is the square root? So some nuisance it will create. अगर ये वो खुद ही स्क्वायर हो जाता तो प्रॉब्लम है, कुछ है नहीं, ये तो पचेगा नहीं पहले. I mean, it will not digest. This constant will come outside. So it is integration a square minus root 23 will form. So it becomes outside. It is a big lengthy formula you might have. Okay. It is a lengthy formula. So you have to remember it. Is how I don't know. I don't know. It is not a good method, good way to solve this problem like this. फटाक से इतना बड़ा फॉर्मूला कहाँ से आया भाई? बच्चे कैसे करें? Am I right?
Yes, sir.
ये जो डिनोमिनेटर्स की स्क्वायर रूट 8 का तो निकाल के बाहर फेंक देंगे, बट ऊपर के तो कैसे ये 4x बाई ये a स्क्वायर माइनस x स्क्वायर, वो भी x स्क्वायर भी नहीं है, तो गलत है. Okay, we will come to know how to solve this kind of. I will try to simplify a little bit more friendly. And here it is dx by x square plus 4x plus 7. And again he made a nuisance here. Okay, in the denominator, if it is okay. In the denominator what happens, try to make a perfect square. चलो बना दिया भाई, तो डिनोमिनेटर का 4 का तो ऊपर निकल के 4 को बाहर फेंको, so we sent outside. And in the denominator, so it is a 2x plus 4 whole square plus 12. See here, in the place of x there is 2x plus 4, so integration, that 2 has to be in the denominator every time, so that's why he made it 1 by 12. And it is a square 1 by root 12 tan inverse 2x plus 4 by root 12. It is 1 upon x square plus a square formula has been used. And then simplify, it will be the answer. Clear? करना पड़ेगा, थोड़ा सा मेहनत दिमाग को यूज करना पड़ेगा. Without application of mind you get nothing. And ये सारी चीज अभी ध्यान मत रखो, ये बढ़ता रहेगा.
अच्छा.
See, अगर यदि कोई प्रॉब्लम ऐसा आया तो हमें रिवर्स अटैक करना पड़ेगा. सॉल्यूशन को डेरिवेटिव करो, सॉल्यूशन को डेरिवेटिव करें तो ये इंटीग्रल छोड़ के बचा हुआ फंक्शन है वो सब. अभी ये 10th लेवल तक ये छोड़ो. हाँ, ये थोड़ा सा दूसरी फॉर्म है. व्हाट इज दिस फॉर्म? कैन यू रीड दिस सेकंड फॉर्म?
In the given integral is of the form integration of 1 by a plus b sine 2x into dx, or integration of 1 by a plus b cos 2x dx, or integration of 1 by a cos 2x plus b
2x. Why are you calling us 2x? Okay, it is in the second form. Go to the first equation.
Integration of 1 by
it is same. Okay, it is understood. It is understood.
Yes,
okay. 1 upon a plus b sin x, 1 upon a plus b cos x, 1 upon a cos x plus b sin x plus c. So whenever you see these kind of equations, then put tan x is equals to 1 by tan x by 2 is equals to 1. So ये तो खतरा है. So how can we remember? So if the integrals are in this form, you have to. It is ये तो ट्रम्प है. अच्छा खासा इंडिया पाकिस्तान का युद्ध चल रहा था, वो ट्रम्प कहाँ से आया था सीज फायर करने के लिए. अब ये बंदा आया तो उसको सॉल्व करने के लिए. So tan x by 2 is equals to, you have to take it. This is, see, it is a sudden surprise. It is not sudden surprise, it is a friendly way actually. It is that he took tan x by 2 is equals to t. Dx is equals to derivative. Tan theta derivative 1 by 1 plus a square. Tan theta derivative 1 by 1 plus a square. Tan x square. Okay, tan x. Its derivative is 2 by 1 plus t square dt. And with this, you will get substitution. Sin theta is equals to 2t by 1 plus t square. Cos theta is equals to 1 minus t square by 1 plus t square. So whenever you see these kind of things, so you have to remember tan x by 2 is t, sin x is 2t by 1 plus t square, cos x is 1 minus t square by 1 plus t square. You have to remember directly like this. Okay. Don't these derivatives and all. Whenever tan x by 2 is equals to t, sin x is equals to 2t by 1 plus t square, cos x is equals to 1 minus t square by 1 plus t square. You have to remember. Okay. And here, even here it is, you have to take tan x is equals to t, and sin 2x and cos 2x and everything will come. It is directly. So here there will be no 2. No 2. It is 2t by 1 plus t square. Everything is same. No problem. But either all are 2x or all are 3x. All are simple x. Substitute and simplify. You will get these kind of answers and simplify. Can you see what is the equation here? It is dx by 1 plus tan x. What he did is, his case is different. Tan x is a rational function, sin x by cos x. Take under LCM and send that side. It is integral cos x by cos x plus sin x. Now it is again one more method. See, there is a big lengthy equation method. So don't attempt this question in this situation only. It is complicated. It is complicated. A, B, L, C, D, K, and then all I equals to, there's a direct formula. It is AC plus BD by C square plus D square X plus so on. So it's a log denominator L minus A. Who can remember this big formula? There must be some technical way. No one can do this. No one will use these kind of formulas in the IIT exam where question leads only 1 minute. That is a problem.
Okay.
And इसका थोड़ा सा जुगाड़ करना पड़ेगा. इसमें प्रॉब्लम्स ही करना होता है. There is no numerator denominator. Okay, you have to do some magic with the e power x and e power minus x. And here you can do either it is a cos square plus b sin square plus a cos sin. So on. So here something perfect square, you have to convert it into perfect square. Okay, I think my screen is not clear here. It is again not clear. All these, they are the partial fractions. A little bit tough to understand and get the solution. We'll see. Now it is 2x plus 5y under root of x square minus 2x plus 5. We need to attempt the question in seconds. Okay. But if you solve these kind of solutions with 7 to 8 lines, it is useless. It is Pakistan. कोई अटैक भी करे तो किसी को पता ही नहीं चलेगा. Okay, I think I solved these questions. Okay, now I'm coming to here. There might be. I thought, what is this? It is question 4, CEQ. I thought, let me come to here. Let me come here. What is this main? These are all CEQ. Yes, main CEQ questions. Download it. Download and open this with this. Open with this draw board. We'll solve these questions there only. I think I already shifted your questions from. So here also I will update these formulas with what are the important formulas there only. Can you see my screen?
Yes, sir.
So this is our full length syllabus of integral calculus. So your point is not for your school IIT exams. Your point is for IIT JEE exam. So I have to give much more inputs to you to get the main exam after that. So list of formulas you have to remember, and that's all I typed, which is up to 59 or 57. 59 formulas are here. Here I will remove some formulas. See, this formula 52 is not required. 51 is important. 52 and 53 waste, because you can solve immediately with fingers. Okay, so those are not required. So crucial formulas only we have to remember and we have to practice. And this is 8.1.1 is problem number 11. I think we have to go problem number 11. They're all previous class problems. X log x plus x. Yeah. So he did the same process. So now let me come to how we got it. Only God knows. Sir, it is wrong, sir. You said that. Now how can we remember? So this is your integral format. This is your integral
Integral
form.
form.
So here what happens? So whenever in the denominator. So for x minus 1, its power is 1. Na?
Yes, sir.
So for this you have to take like this. Okay.
If it
But
is square,
if it is square, then take b by x minus 1 whole square.
okay.
But here it is not, so we don't take. So come to here. Next, what you have to take, plus for x it is b by x, and x square is there, so therefore it is c by x square. Clear?
Yes, sir.
Am I right?
Hmm.
So now what happens? I will solve these problems at here. So integration of x plus 1 by x square minus, x square into x minus 1 into dx. Okay, I will rub this, and I will show how we got from this portion to this portion. And I should not provide the detailed solution. This is for the understanding purpose only. Once you reach this, everything is simple, but reaching up to here is most important. So here what happens here? So you have to write, which is first of all, don't write this integration and dx. Okay, you have to take up to here, and which is equals to what happens here? It is a simple powers. Take a by x minus 1. This one factor is completed. Plus b by x. It is square repeated. Plus c by x square. This is a consideration. Now what we have to do? We have to write it is x plus 1 by x square into x minus 1. That is as usual. And here we have to take triple LCM. What happens? What is the LCM of these three? The LCM of these three is x square into x minus 1.
Yes, sir.
Okay. And here a into x square, not x cube. Remember. Okay. A into x square plus b into x minus 1. Okay. B into x minus 1 plus c into x minus 1. Clear?
Yes, sir.
You should understand this partial fractionation. So then this is cancelled. So your left hand part is equals to right hand part. Is x plus 1 is equals to. So now accumulate. What is x square coefficients? What are the coefficients of x square? It is a. So one coefficient x square will come from this.
Again,
It is
b
a plus b into x
plus
square.
b into x square.
Now write down the coefficient of x. This is completed. Here minus b will come, and here c is there. It is c minus b
B
into
plus
x.
okay, c minus b.
And there is no constant, it is minus c. Clear? So here what you have to do, compare the coefficients. Compare the coefficients. So what is the coefficients comparison? Is there any x square term in the left hand side?
No.
No. Therefore, a plus b is equals to 0.
Okay.
What is the coefficient of x?
1.
Here it is 1. What is here?
C minus B.
Therefore, c minus b is equals to 1.
Okay.
What is the constant?
Minus
What is the constant?
1.
Minus c, the right hand side.
Yes, sir.
So minus c is equals to 1. Speak loudly. So here, so your c is equals to minus 1. And when you substitute this minus 1 in the previous equation, it is minus 1 minus b is equals to 1. So that is and
Okay.
comma. So it is minus 1 minus b is equals to 1. B go to this side, minus 1 comes to this side. Therefore, b is equals to minus 1 minus 1 implies b is equals to minus 2.
Minus 2.
We got b is equals to minus 2. B
We
c is equals
substitute
to
in A.
minus 1. If you substitute here, you will get a is equals to 2.
Yes.
Then you can write here, sir, what is this equation? So you can write this equation as which is equals to a is 2 by x minus 1 plus b is minus 2 by x plus c is minus 1 by x square. Is it clear? This is a partial fraction process. He took the same. What he took? Oh, he made a mistake then. X is equals to he got minus 2. He got x is he got b is equals to 1. Let me check b is equals to how it is 1. What is the b value? C minus b. It is c minus b 1. C minus b is equals to 1. The c is equals to minus 1. And b equals to minus 2. C minus b equals to minus 2. Minus 2. I think the answer is also wrong. No, answer might be right. Minus 2, 1 plus x, 1 plus x, 1 by x only is there. Let me check, be carefully. B. A plus B, A plus B, A plus B. C x, it is minus bx plus cx. C minus b is equals to 1 only. What is the numerator? X plus 1 only. And the b is equals to c. C once it is c is minus 1. Is there any plus b? No, it is minus only. Minus 1 minus b is equals to 1. B is equals to minus 2. B is equals to minus 2 only. I will check the problem. Okay. Error. Minus 2. So it is, now I got it. It is minus 2 only. Okay. So once it is minus 2, here it is wrong. It is minus 2 only. So here what happens? What is the x minus 1 derivative? Here you will come.
1.
To have to 2 send outside is 1 upon x minus 1 into dx. And you have to keep minus 2 outside, minus 2 integral 1 upon x dx. And this minus outside integral 1 upon x square into dx. If you do simplification, the answer will be, it is 2 log mod x minus 1 minus 2 log mod x minus, it is minus 2 plus 1 by minus 2 plus 1. I written direct answer. And if you simplify, it is 2 common log of mod x minus 1 by x plus 1 upon x plus c. Yeah, the option is 2 log mod x minus 1 by option number 4. Option number 4, not 3.
Yes, sir. 2 log.
2 log mod x minus 1 by x. It is typed the questions. I will change. So that's why I'm explaining these problems. But in the next class, I will scrutinize all worksheet wise.
Okay. Okay.
So next. What happens here? Hmm. Yeah, this is the answer. Okay. So now go to the next question. See, this is a famous substitution, Weierstrass substitution method or tangent half angle substitution method. The Weierstrass did a lot of work on these problems. It is 1 upon, what is the form? 1 upon 1 plus a plus b sin x. If a plus b cos x also, you have to go to the same method. Is it clear?
Yes, sir.
So here you have to take t is equals to tan x by 2. Then sin x is equals to 2 tan theta by 2 plus 1 upon y 1 plus t square. You should remember those, it is not dx. It is cos x. Okay. Error. Cos x is equals to 2 by, oh sorry, it is dx only. It is dx because we don't need the cot x, the sin x. We need it is cos x. It is t and dx and this is sin x. You have to remember this and directly substitute. So it is 1 upon 4 plus 5 to d by 1 plus t square into 2 by 1 plus t square into dt. After simplification, you will get so and so. You will get so and so. See again. So it is, see, it is an in-depth problem. In-depth problem. So once you reach these partial fractions, it is what happens. It is he made partial fraction. 4t square plus 10t plus 4 is equals to 4 of t square plus 5 by 2t plus 1 is equals to 4 taken common outside and made of partial fractions. And it becomes 1 by 2 into, it is 1 by 2. It is 4 whole square. 4 whole square. Is there any numerator do? Numerator we have already 2. So by 4 becomes 1 by 2 outside and integration 1 upon t plus 5 by 4 whole square minus 3 by 4 square. It is C. Integration of 1 by u square minus a square du is equals to 1 by 2a. It is minus. It is not tan inverse. It is minus. It is simple. We already proved just now. And then simplify and then simplify and then simplify. 1 by 3, 1 by 3 log 2 tan x plus 2 plus 1 by 2 tan x by 2 plus 1 by 2 tan x by 2 plus 4. Option number 4. Is this clear?
Yes, sir.
The problem is okay, the solution is okay, and the option is there. I think this kind of explanation is good for you. Is it okay?
Yes, sir.
Can I write all questions like in this form?
Sir, right? No problem.
Okay. Next. So now it is another situation. So we have to remember another formula. It is integral 1 by under root of 9x square minus 25. You can see it is something a little bit friendly. Okay. It is a little bit
Sir, it
friendly.
is a square minus b square.
A square minus b square, but we don't want that formula. We want it is 1 by under root of 3x whole square minus 5 square into dx. But
Yes, sir.
this is inside the square root. It is a problematic. So you have to remember its formula. What is the formula you have to use? I think he mentioned here. It
X
is
square minus a square.
1 by under root of u square minus b square. Here the formula must be used 1 by under root of 1 by under root of x square minus a square into dx, which is equals to 1 by a cos h x by h inverse x by a plus c. This is the formula. Okay. 1 by a cos h inverse of mod x by a plus c. So it is a standard formula. So just simply apply, you will get our answer. But you should remember this formula. So in the examination, without these formulas, can you attempt the question?
Mhm.
Then so everything is most important. Everything is most important. And we got headache. It is similar formula. It is similar formula. It is similar formula. So under root, we have direct, but we have direct method. So under root of x square minus 4x minus 5, try to make a square. It is x minus 2 whole square minus 9. It is x minus 2 whole square minus 3 square. So there might be 1 upon 3 now. It is 1 by a cos h inverse x by a. Previously we have seen. Okay, and I will check the options here. Okay. He used some logic. He used some other
Sir, in
logic.
last step it is x minus 2, again it is x plus 2.
That's wrong. Error. Okay. Error. I'll simplify. Okay. Here x minus 2 by 3, x minus 2 by 3 only, but outside it will be 1 by a cos 1 cos h inverse x by a plus c. So it will be 1 by 3 cos h inverse x minus 2. X minus 2, no issue. It work like x only, but 2x minus something, it becomes damage. One coefficient has to come by 3. Okay. So what is this problem number? This is problem number 15. So in your worksheet, your 15th problem will be the same. The 5th problem. How? He also made the same question. Cos h inverse x plus 2 by 3, x minus 2 by 3. How it is possible? I don't think so. There might be some error here. There might be some error. 1 by 3 will form. Can you cross check the solution in your booklet? Must be 1 by 3. He might be opted option 3. But who will give 1 by 3? Let's check our formulas also. हमारे पास कुछ formulas पड़ा हुआ है. What is 1 upon under root of x square minus a square?
Sir, you are in worksheet 4.
Worksheet 4, problem number 5.
3.
Worksheet 4, problem number 5.
Yes, sir, 3. It is answer.
Answer 3. But it is... Oh. So there is no 1 by a. Can you see? If there is no 1 by a, why are we working in the previous problem? While doing these kind of mistakes, now we can remember the formulas also. Then this is okay. This is okay. But here still error. Here it is still error. This must be plus. Okay. It is mod x minus 2 by 3 only. Means this is wrong. This is only right. And here, why did we made here 1 by 3? Oh, this is wrong then. Why he made 1 by 3?
Sir, a is equals to 3.
No, here ax square is there. Okay, it is not x square, it is ax whole square. So 1 by a as a part of integration it will come, but this is your standard form. Okay, so here this is right, and there it will be. This is right. Okay.
Sir, if it is ax, we will get.
I will give the formula. See here, integration 1 by under root of x square minus a square into dx is equals to cos h inverse mod x by a plus c. That's it. I'm giving another formula. Integration 1 by under root of ax plus b whole square plus c square into dx is equals to cos h inverse. What is in the place of ax plus x? Here it is ax plus b. Am I right?
Sir.
In the place of a, there is c. We are not writing c. Okay. And here in the place of x, there is ax plus b. Therefore, here 1 by a will come. Am I right?
Yes, sir.
क्योंकि x की जगह x अकेला नहीं भाई ax plus b है, तो बस ये x के कोफिशिएंट फिर वापस आएगा डिनोमिनेटर में. अगर यदि डेरिवेटिव होगा तो प्रोडक्ट में आएगा. So this is your formula. Okay, so with that, so we have completed these all 5 CEQ problems of the 4th worksheet. Now let me come to your 5th worksheet. Where is the worksheet? It is the mains. It is second worksheet, second level problem. So these are the third level problem. Level 1. Download. PDF has been generated. Open with the trouble. So here last two problems are your in this level you have 3. This is your fourth problem. So you can come here. What is your worksheet 3? It is sin x by under root of 3 plus sin square x. Sin x by under root of 3 plus sin square x. Is that the same problem?
Yes.
Okay. But I want to take a break of 10 minutes and we'll come back. Okay.
Okay.
Before that, let's wind up this class and we'll join back after 10 minutes. Here we are. The class has completed of 51 minutes and we'll take a break of 10 minutes. Then we'll join back at 8:40. Let's complete the break.